great work you've done, and I've had a chance to come here a handful of times over the past several years, but it's been a few years, so it's really good to be back. I really appreciate you guys being here. When Kurt and I tried to schedule this, I thought, oh, this would be the perfect week. It's not the last week of classes, but it's after the break. Well, I just found out this is your last week. So I really appreciate that you took the time to spend with me. I'm going to cover a lot of the terrain that Kurt talked about in terms of the program at Rensselaer, but then also how that can be ported into a new context, what the common challenges are, and what maybe some possible positive responses to those challenges might be. One qualification, this isn't exactly a tightly woven research presentation. It's space I spent a lot of time working on and thinking about and writing about, but this particular line of argument is being piloted with you today. Okay, so by way of introduction, let me share that I am an engineer, but I don't do engineering work. What I do is teach design courses that integrate technical, social, and creative approaches. I develop interdisciplinary design curriculum. I teach engineering students the social dimensions of technology innovation and engineering practice. I direct an interdisciplinary engineering department with faculty representing engineering, design, and the social sciences. Now, I once was a practicing engineer working in the automotive industry, but even then, I didn't do real engineering work. What I did do was to ensure the integrity of suppliers' quality management procedures and documentation, troubleshoot quality problems at Ford's Kansas City assembly plant. I liaised between assembly plant managers and parts suppliers. I harmonized the perspectives of design engineers and manufacturing engineers. I coordinated between the US setting and the preceding European assembly plant. But I never used a calculator except when I submitted my expense reports. In 2.5 years on the job, the closest I got to an engineering problem was one time using rudimentary probability and statistics. So to be fair, I'm not really an engineer, or I'm not really a real engineer. I may have an undergraduate engineering degree. I may have industry experience as a titled engineer in a prototypical engineering industry. I may even direct an academic department with the word engineering in its title. But that department also has the word society in its title. And that latter word signals that this department is not really a real engineering department, at least not in terms that we are all likely to agree define the essence of engineering, its technical core. In the spirit of full transparency then, I'll share that my PhD is in Science and Technology Studies, or STS, which is squarely within the domain of the social sciences. And my research is focused on the social, cultural, organizational, and epistemological dimensions of engineering, engineering education, and engineering practice. While my work revolves around the theme of social technical integration, I don't actually focus my attention on the technical side, or at least not what we traditionally understand to be the technical core of engineering. As highlighted in my department's webpage, our specialty is not the technical core of engineering, but the roles of problem definition and social context in technical problem solving. Two areas traditional engineering programs would never highlight as their core expertise. So I don't do the technical core, or more precisely, I don't do the technical core from an engineering point of view, but I do it from a social scientist's point of view. My work highlights the centrality of the technical core to engineering disciplinary worldviews, and how that worldview erects barriers to social technical integration. There are other barriers, which I'll get to later in the presentation, but for now I'll focus on the technical core. There are many practical challenges to interdisciplinary programming. I'll also get to some of those, But my main theme for the talk today is how disciplinary worldviews, in fact, how our very conceptions of engineering expertise create conceptual barriers to social technical integration. By conceptual, I mean to highlight how it is that we construe engineering, both from inside as engineers and from the outside as social scientists, as designers, as ethicists, etc. So I'll ask rhetorically, what is the primary impediment to social technical integration? What if the primary impediment to social technical integration is how we define engineering? Namely, that, quote, real engineering is technical analytic work, and that the vast amount of non-technical work that engineers routinely carry out in practice across professional domains is somehow understood as not actually engineering, at least not true engineering. In this talk then, I explore some of the barriers to social technical integration that arise in dominant disciplinary approaches to engineering education and real-world problem solving. I'll overview a few integration efforts that I've been involved in, describing how they played out in practice and how we might improve upon and extend such practices. So, social technical integration is the objective of my work, but it's also the empirical ground that I seek to understand. And to understand this ground, I'll provide some theoretical touch points for my analysis. So I'll open not with a robust theoretical framework, but instead some theoretical touch points that are relevant to the intersection of the social and the technical and engineering. Then the empirical context of my talk will draw on cases drawn from the major thrusts of my research and program administration work over the past several years, spanning instructional strategies, student experiences with educational culture, and most recently, departmental identity building. So the first case, instructional strategies, and here I'm going to review some of my experiences administrating the teaching of engineering, social, and technical dimensions in the PDI program that Kurt referenced as social and technical as co-equal components. Now the second case I pulled out for timing purposes. I designed the talk for a little bit longer of a window. But for those of you who have an opportunity to meet with me later, if you're interested in talking about student experience with ethics culture, that's another thread of my research. And then the second actual case I'll discuss here is department identity building. And this is the work that I'm doing now in a new institutional context at the Colorado School of Mines, trying to replicate some of the successes of PDI. Okay. So for each of these, I'll provide a little bit of context, including broader goals around social technical integration and the structure of the intervention, describe a little bit of the practical challenges in achieving those goals, but then my focus is going to be on the conceptual underpinnings of the practical barriers to social technical integration. Okay, and I'll conclude with reconceptualizing how it is we think about and practice integration. Okay. So the analytic context, the theoretical context, draws primarily on work in STS, but many of you may know classic work in the schism between everything social, humanities, arts, social sciences, and what STS folks nowadays call techno-science. STS is Thomas Gearing's work on boundary work in sciences and how scientific disciplines very deliberately and self-consciously manage the division between what is science and what is not science. And then more recently, so STS has a long tradition of work on expertise and its nature and character. Collins and Evans have a highly controversial analysis and criticism of much of the work in STS, which sort of asserts that STS has gone too far in deconstructing and contextualizing the scientific knowledge and the authority structure that scientific knowledge is based upon, and sort of offer a defense of true technical or techno-scientific expertise. So sort of moving from broad disciplinary divisions through how those divisions are managed to what is core to expertise in the techno-scientific world, or for that matter, in the social scientific world. So let me jump into my cases. So first case, instructional strategies. So again, in each of the cases, I want to provide enough context so you understand a particular sort of intervention. But the intervention is very highly focused, a very specific empirical touch point that raises certain challenges that then deserve sort of thinking about what is the conceptual underpinning that really makes this so hard to do. So the Empirical Space is Rensellier's Programs in Design and Innovation. I'll use the acronym PDI, Programs in Design and Innovation, which is a set of coordinated, integrated, dual major programs at Rensselaer. I was at Rensselaer for 12 years as a faculty member prior to joining Colorado School of Mines in August, just this August. And most of that time I spent building and directing this dual major, set of dual major programs. Okay. The program structure, as I just said, is dual majors. So you have this social scientist, this STS embedded degree called Design, Innovation, and Society. And then that is coupled as a dual major with a whole range of, quote, technical disciplinary programs. Now, technical is used loosely, maybe better would be quasi-professional, but the vast majority of our students, it was Rensselaer after all, are engineering dual majors. More than 85% of our students are engineering dual majors. So students get this dual major, DIS, plus predominantly mechanical engineering. As a dual major, the entire curriculum is specified down to the credit hour, right? Every single one is determined, no pre-electives. And it looks exactly like this. So you see the traditional techno-scientific courses. Then there's also a parallel, continual, if thinner thread of humanities, arts, and social science courses. But then the sort of what made it compelling as an educational experiment is the integrated design studio, which Kurt mentioned. So Kurt TA for one of these. Design every semester. Most of those semesters, it's an interdisciplinary design experience. Some of those co-taught, which I'm going to talk about at greater length. So studios 1 and 2, the gateway studios for students entering this program, were co-taught. The original model for the program was actually every studio was co-taught, and every studio was co-taught by 3 instructors, 1 from engineering, 1 from STS, social sciences, and 1 from architecture and design. Can you imagine the educational experience? Can you imagine the administrator's response? So obviously, that is not a viable model. And over time, it got whittled until we had these 2 studios left, co-taught, an engineering faculty member and an STS faculty member. And I spent my 7 years as the director of the program assertively maintaining that boundary. Because, and I was able to effectively argue, the spirit of the program is conveyed in this co-representation of instructors from the beginning of the program. Yeah? So these 2 design studios, 1 on creativity and visualization, 1 on design process and design methods, were taught by both an STS and an engineering faculty member. Despite our success in maintaining the co-instruction in those 2 courses, and these courses have about 30, maybe 35 students in them, right? So big for a design studio, but not huge for a 2-instructor course. So despite our successes, co-instruction is really tough, especially across the social technical divide. So as promised, some of the practical challenges, of course, costs, as I alluded to. Instructor fit. You need the right sort of instructor who has the ability to co-teach. That's probably true within a discipline, not to mention across disciplines. A certain amount of expertise in collaboration across disciplines. And then, of course, topical expertise that's relevant to the course. Although I'll say, after many years looking back, the topical expertise is probably the least important of that whole list. But what I want to focus on is the challenge of the two cultures. So the challenge of not only co-teaching, but collaborating between the technosciences, or engineering in this case, and STS. So this is a model for the program that I built after working in it for many years. So this is an idealized model, but it does convey the sort of traditional, or the original vision of having an STS person, an engineering person, and an architecture person. So formal here means form, attention to form, color, texture, shape, right? The things that designers and architects care deeply about and know, and the basis of their expertise. So you have these 3 distinct analytic modalities happening simultaneously in the design studio. But of course, design is about solution posing, not just deconstructing and taking things apart and analyzing, but putting things back together and proposing creative solutions. So we have this combination of the structured analysis embedded here, all along with creative synthesis. So this is the sort of idealized approach to both the design course, but also the disciplinary integration. So the challenges of co-instruction are many. I alluded to some of the practical ones, but conceptually, it's also really hard, and including especially across Snow's 2 cultures divide, the sort of technosciences and the social sciences. Probably particularly so, or uniquely so, or done in a unique way in the context of engineering. So even my dean today is very quick to assert whenever there's any question about whether or not we are covering the technical core, whether there's rigor, the bridges must stand, right? We need to center on a technical rationality and a technical skill set to ensure the integrity of the artifact. That's a really compelling articulation for justification for an engineering worldview. But it's also totally disabling to a social scientist's involvement in the process. So because I can't do the statics, I can't contribute to thinking about what a bridge ought to be as an object in the world. The engineering model, of course, technology improves society, and all of our engineering programs recruit on that premise, right? You want to change the world, be an engineer. Presumption, you don't want to change the world, be an English major? I'm not sure, but okay, we all want to change the world, I hope. And then educationally, a preponderance of energy to functional tuning. My advisor and the person, the sort of grandfather of PEI, one of my advisors, call this technical nitpicking in the design classroom. Just like take all the details apart, tick, 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 tick. Not to say that it's necessarily distinct from how social scientists work, but in a different realm. Okay, so contrary, the STSers would practice in the classroom, in the collaborative classroom or the co-teaching environment, what I would describe as meta-expertise. They would try to get on top of the engineering knowledge, very much like I'm doing now, right, to contextualize it. This is a fascinating dynamic in our design classrooms. We have these students who really want, they like the political orientation of this design program really is change the world through design. And the engineers are saying, yes, technology changed the world. And then you have the STS faculty very often in the same classroom saying, no, technology is making things a lot worse. Can't you see? And of course, there are plenty of empirical cases, plenty of empirical examples where you can demonstrate exactly that. So the role of technology sort of is also negotiated and struggled over. And then this one I think is probably most challenging. The impetus for social scientists, but particularly STS scholars, particularly in the Rensselaer context, to deconstruct, and I have a few Rensselaer folks here so they can verify or contradict. But taking apart, forever taking apart any claim of authority or of any solution, always identifying 1,000 limitations to any proposed design solution. And I myself feel that I'm guilty of that sometimes, right? It's so easy to quickly see 1,000 reasons why any student's design concept may not be successful, may not work out. So in some sense, in the classroom, even in the classroom in front of the students, despite our insistence that the co-teaching was crucial, and I believe despite these shortcomings, the co-teaching was crucial. And yet, we see very predictable disciplinary dynamics, power dynamics, playing out in this context, where both instructors are presumably there to contribute to the learning of the students. So for the engineers, we see consolidation around the technical core, and what I would characterize as a retreat to the sort of dominant authority of technoscience. And 18-year-old, 17, 18-year-old students are very comfortable with the dominant narrative of the authority of techno-scientific knowledge claims, yeah? So in some sense, the engineering faculty have that. But it's not totally fair to blame them for relying on that power dynamic, because the STS instructor in the classroom is often trying to deconstruct the authority out from underneath the engineering instructor, who too is trying to practice and engage students in a sort of worldview building, right? So whereas this, I'm very frequently critical of engineers for going to this space to resist alternative interpretations of their world or their educational paradigms, that they do it in response to this dynamic, where the STS professor tries to contextualize and contain the engineering authority, is, I think, not surprising at all. So this sort of power negotiation through the authority based in the distinct disciplines is very, very tricky in a co-teaching environment, even among instructors who are experienced and actually know something about these dynamics. Okay, case two, which I promised that I wouldn't cover, but I wanted to sort of give you a sense of the arc of the analysis, is around student experiences of educational interventions that are targeted at changing the engineering educational culture, specifically regarding ethics. And Rensselaer had an interesting initiative called Honor the Code, where it was a student orientation activity, and they really tried to get students thinking in an excited way, positive about ethics from the start, in order to enact more ethical behaviors, not cheating, as they move forward. And I can talk about this offline. I have an NSF-funded project on informal ethics learning at Rensselaer, and this is one of the data points from that study. Okay, so for my second case, I'm going to talk about my new institutional context at the Colorado School of Mines, where I'm now department head. The title is division director, but division is a small department. So I have 12 faculty under me. It's a brand new department, and there are lots of opportunities and challenges associated with sort of operationalizing this integrative approach that I characterized in the PBI context. Okay, Colorado School of Mines, Engineering, Design, and Society.
Did you get the data?
No, but when I applied for the job, even though they told me I wasn't, among their targeted list, it was so perfect. I just walked in and I said, "You wrote this for me, right?" No, I'm sure there are 4 people in this room who are more qualified. Okay. So, engineering, design, and society. 3 independent organizational units brought together to form a new department. 2 units are design service units. One, assume in order, capstone design, senior design. Two core sequence, industry-sponsored projects, engineering students do real-world design. Not a totally innovative model, done pretty well at Mines. I'm impressed with how well they do it, but neither pedagogically nor conceptually particularly compelling. Cornerstone design, which is first semester design, which is like many institutions' first year engineering programs, right? A little bit of design thinking, a little bit of professional communication, a little bit of teamwork, a little bit of ethics, etc. Third unit, and both of those units are service units. There are teams of faculty, exclusively teaching faculty in our institution, so not research faculty, not tenure-line faculty, teaching faculty. Teaching 100% service. They are on call to the engineering programs, yeah? And then this third program, humanitarian engineering, which is directed by a social science person, an STS person, which had lived in the School of Humanities, Arts, and Social Sciences, but was then brought into this new department, Engineering, Design, and Society. 3 distinct units brought together to be a department. So, a practical challenge, just getting folks to be committed to a department and a department budget, a department identity, rather than sort of maintaining the history of the independent units, right? So building departments is really tough. Building them from scratch is really tough. Building them not from scratch is a lot tougher, right? Because people have momentum, and they have agendas, and they have relationships.
Dave starts twitching.
But intersecting with the practical challenges of building a new unit from existing units is the conceptual challenge of bringing distinct areas of expertise together in a similar sort of framework that I provided in the last case. So our capstone design instructors, well, I'm going to characterize them as engineering expertise, but they're really industry people, right? Engineering industry people who really care a lot about what they would call the real world skills, preparing engineering seniors to hit the ground running in industry, yeah? So this entails a lot of attention to technical analytics, but also a lot of attention to teaming and working with the client, etc. The Cornerstone group, now these folks disciplinarily are more all over the map, but the core cohering identity would be design thinking. And I'm an advocate of design thinking, having directed a design program for many years. I'm also sympathetic to criticisms of design thinking. I'm not sure I'd go as far as Lee Vinzel at Virginia Tech, who calls design thinking similar to syphilis, because if it's left unchecked, it eats your mind. I don't think it's that bad, but there are certain challenges to creating
Lee is
academic
never
programming. So our design thinking folks, context, and as I already said, the social scientists all living in humanitarian engineering. Now, of course, it's not neatly divided. We have industry folks in the design. Most of them are, not all, most of them are engineering credentialed. The social science folks also have people with engineering credentials, right? It's a hybrid department. But those sort of disciplinary experiences and expertise really sort of drive the programming in those three areas. Okay, so here's the program structure for this new department's new undergraduate engineering program called Bachelor of Science in Engineering. Now, it looks a lot like a curriculum you saw previously, partly because I copy-pasted that graphic, but partly because they designed, and this is they, because they designed it before I got there, largely based on the PBI model. But also because it actually makes a lot of sense in the context of an engineering curriculum. ABET mandates that. There's not much latitude there. ABET allows this, and most institutions have internal requirements that mandate something like this. Then really the question is what to do here and here. The specialty area would be conceptually parallel to the disciplinary courses in a traditional engineering program, right? So if this is your engineering sciences core, this is your mechanical engineering courses, if it's mechanical, say. But what they were able to do to get through their students, the institution's curriculum committee, is to define the specialty area, which could be technical or social, or ideally, some hybridization of the two. So that's a really interesting curricular opportunity. And the specialty areas can be different sorts of things from aerospace engineering to music, right? So vastly different ways to conceptualize what a specialty is for an engineering program. Yeah. But then also we see the reemergence of this design every semester. Now, Cornerstone stays, Capstone stays, those programs persist as they are. Hopefully over time we'll modify them to plug better into this. But here, in these middle design studios that don't yet exist, there's a real opportunity space for deep integration. Of course, then the question becomes, who teaches that and how? So, despite the disciplinary differences and the impulses, the associated approach to problem solving that are embedded in those disciplines, this department, and again, this was written before I got anywhere near, website, we believe that people with their creativity, varied intellectual capacities, sentiments, beliefs, and cultural traditions are the central players in understanding complex problems and scoping just. Well, that sounds like a program I want to be affiliated with, right? And it's an engineering program too. Well, it's not a real engineering program, but we've already covered that. Okay, so in this context, most of the problems are in front of me, and I've been there just long enough to start to get a handle of what they are. But we absolutely see the competing disciplinary priorities playing out there. Again, centrality of function for engineering, centrality of process for the design people, centrality of stakeholder engagement for the social scientists. Now, I like my social science colleagues a whole lot. In fact, that's why I'm there in a very immediate sense. And I love their work, and their humanitarian engineering work is great. But the entire campus basically understands social sciences as stakeholder engagement. It's an incredible reduction of the field, and yet it's effective in that context. And then the engineers are really focused on industry preparation. That pretty well repeats in Cornerstone. It probably would be equivalent if Cornerstone weren't 18-year-olds instead of 22-year-olds or first-year students, right? It's just they're so distant from their industry lives. But the social scientists are not about that at all. They're really about creating change agents, and most of their graduates, I assume, they would prefer not to land in traditional engineering jobs and instead be wherever, the Peace Corps or development NGOs or wherever. So this, not surprisingly, is playing out in my new home. It's really complicated by countervailing institutional forces. So we have the technical engineers and the less technical design/engineers and the social scientists. So sort of the dominant disciplinary hierarchy, I'd say, that's ordered like that. But fascinatingly, our social scientists are the tenured faculty members, and all the rest are teaching faculty members because of the institutional history I shared. But think of how this fusses up the power dynamics, right? So you have the social scientists who actually have a contract that lasts longer than a year, and who are the research active faculty, and who have budgets, research budgets, to be able to do things, to be able to buy faculty right out from the design classes and put them into social science classes. So this is a power dynamic that is very atypical, and certainly one that I'm not used to dealing with. And then third, we have the institutional status at the School of Mines, which is like Rensselaer, a prototypical engineering institution, where, you know, the engineers, well, they do this professional stuff, and they do this design stuff, the engineering, this is senior design. They're engineers, certainly, but they're not doing engineering research, so they're not the top quartile, but they're in the third quartile. But ironically, the social scientists, because it's science after all, and also because they're research faculty, have a secondary status, whereas these folks doing first year design, it's like, are they really even academics? Right? What is it? Is that scholarship what they're doing? And so institutionally, we have a distinct power structure from the other two. So I'm looking forward to sorting all that out and trying to get folks, if not on the same page, on a similar page. Yeah.
Do you count the temporality as one of the power dimensions?
Temporality of contract?
No, the design, get the students first.
Oh, when they're in.
The
No,
social
I don't.
sciences
I
in the middle and the engineers
Yeah,
at
I
the
should.
end.
I should. But the social scientists also have them at the end. So the humanitarian engineering are junior and senior classes along with capstone design.
I'm just thinking that, yeah.
Yeah, it's interesting.
Freshman design, capstone design, and
Right,
stuff. Sort of.
right. Thank you. Okay, conclusions. Promising responses. So, how can these cases help us rethink the challenges of social technical integration in engineering education? What sort of responses are needed? I'm gonna rely on this model, which I actually continue to believe is viable and let's say desirable. What is the Trinity? Viable, desirable, feasible thing.
Realizable, yes.
So how do we practice, even normalize social technical integration or social technical design integration? In the context of design, social technical formal integration, and do we need a new core to do this? Do we need a design engineering core? And this is where sort of my branding impulse is for our new program, right? We know what engineering design is, but design engineering actually hasn't been owned yet, at least not widely. So maybe that's where we're going to live. But actually, I don't think we need a new core to think about it in terms of a new disciplinary or interdisciplinary core. Rather, I think that we need to rethink how we collaborate, what we actually do, and what we strive to achieve in the educational context of social technical integration. I think we need to move from prioritizing the disciplinary core or even multiple disciplinary cores to conveying disciplinary worldview, right? So not to undermine the importance of the core, but to contextualize it in a way of seeing the world. Move away from converting students or colleagues to our worldview toward fostering whole new identities. This, I think, is particularly important for undergraduate, interdisciplinary undergraduate programming. They're not going to be STS students. They're not going to be typical engineers. They're going to be something that we can anticipate, and we need to allow them. I think we need to move away from a simple additive approach to education where it's like, and like even our curriculum models, right? You add this, and you take this, and you add this, and it's just all componentized to an intersectional approach, right? Where they're not neatly, mutually exclusive, culminating entities, but that it's a complexly intersected and overlapping approach to education. Move away from defending disciplinary turf. This is an easy one, but in the context of design pedagogy, the alternative is readily apparent. Move toward a model where each discipline contributes what it has to the problem at hand. And I think that we all can easily do that. We may choose not to for a variety of reasons. We may prefer to deconstruct, but deconstruction can be used in the spirit of creating solutions to problems as well. So further, more fundamentally, I think it's worth interrogating our very models of expertise. Both our own, like the expertise that I have as a social scientist / maybe not real engineer, but as well as how we think about expertise itself as a mode of knowledge and authority as it intersects with our educational strategies. So rethinking expertise from being definable, distinct entities to being indefinite and overlapping. And here, this is good after dinner and drinks conversation, but Collins and Evans rethinking expertise like the defense of core expertise of highly specialized sciences plays so poorly into educational programming because so few of the problems that students work on, certainly in design classes, have that narrow focus, right? Real world problems are inevitably messy, multidisciplinary. So to teach students to approach those problems with a disciplinary framework is arguably fundamentally flawed. I would argue that we too often think of expertise along a spectrum, and Collins and Evans play right into this, right? You have more or less expertise, as if the domain of that spectrum is specifiable, instead of course, we all have different areas of focus within a domain of expertise, and any time you get too narrow, there are 1,000 equally narrow points of intersection or points of depth, even within the same discipline, right? So the design people talk about the T-shaped individual, but of course, right, like everybody's got a disciplinary thing and then a lot of parallel expertises within that domain, but also in other domains, adjacent domains or distinct domains. I think we need to move from thinking about expertise as independent, alternative, and as relational and intersecting. I alluded to that with collaboration. And we need to think about moving from knowledge as cumulative, just like we think of our curriculum as cumulative, and to thinking about it as complementary but contextual, right? So it's not just you take the engineering expertise and you add on top of it the social science expertise, and you therefore have a more robust worldview. No, actually you have competing, fractured worldviews that sometimes complement but sometimes contradict. And then move from thinking of divergent expertises as competitive to largely, partly incommensurable, right? So the expertises don't have to talk to each other to be put productively into play. But that's different from being competitive, where they're being where one is defending against the other. Okay, so that's my talk. Thank you.